Good morning. So I want to continue the lesson. Of course, this is also part of the lesson, but let me start completely from scratch. Mainly, I will recap what you are supposed to know from Ma3c on this topic. Okay, so that's also something that is part of this course as well. Okay, so let me just tell you what we did before. So if you remember, I hope that I could motivate you that the notion of derivative from math point of view and from, for example, physics point of view are important. And then we come up with a formula for a very specific form of limit, which we call this is derivative. So f prime of a is defined to be the limit of f of a plus h minus f of a divided by h goes to 0. Okay, so that's an abstract notion. So when I give you a function, and when I give you, so I give you a function f, I give you a point a, and then regardless of what are the meanings of f and a, you put them in this formula, you calculate a number, that number is called the derivative. So that's the abstract level. But what is the meaning of this number that you calculate is also important. So this is very important for our lesson in chapter 2. And then this diagram is something that I want you to have it in the back of your head. That is the geometrical interpretation of this number that you get. So let us say that I have the graph of this function somewhere. So this is the graph of f of x. And this point that you see here is the x coordinate of a point on the graph. Let us say that this point is a. And now if you draw a tangent line here, yes, this tangent line has a k value, okay? The k value of this tangent line is the geometrical interpretation of the number that you get here. So that is f prime of a. So these two things I really want you to know. So this is the definition of the derivative of a function at given number. And what you get as the output, you get a number at the end. If you calculate that number, what is the geometrical interpretation of that number? That is the slope of the line tangent to the graph of the given function at a point on the graph whose x coordinate is a. So if I want to summarize that, what is a? A is the x coordinate of the tangent C point. So let me give it the name capital T. So this point here is capital T. Yes? So this is what we learned before, okay? But now let me, for example, give you an example to refresh your memory. So example, and by the way, if this limit exists, there are some terminologies, it's a little bit different from the Swedish language. I want you to also know that word. If you can calculate and a number comes out there, so this means the derivative exists. So if this limit exists, we say that the derivative exists. Instead of saying that the derivative exists, we simply say that the function is differentiable. So this is the English word that we use, differentiable. Of course, to emphasize more, at which point? At point A, yes? Something like that. Okay, now let me give you an example. So let f of x, I give you a simple function, f of x equals to, for example, 2x to the power of 3 minus 2. Okay? Determine, so f prime of minus 1. Okay, so let me emphasize, because sometimes in the national exam, because you know that later we can solve it in a matter of seconds. It's a very simple exercise when you know the rules, okay? But sometimes they force you not to use the rule. So they force you to use this definition. They say using the definition of the derivative. So whenever you see this, or sometimes in English they say using the first principles, you have to use this formula to calculate the derivative, even if you know the rules, because you know that this is a very simple exercise in Ma3c. So you calculate the derivative, it becomes 6x squared, and you replace x with minus 1, you get the answer in a matter of seconds. But if you see this phrase in the question, it means that even though your answer might be the correct answer, you're not allowed to do that in that way, okay? So they want to test your knowledge, how much you know about using the definition. Okay, so what I want to do, I want to calculate this using my definition. So the first thing that I will do, I will rewrite the formula, but here, minus 1 is playing the role of my a. So f prime of minus 1 becomes equal. I have to replace every a with the given number. So this becomes f of minus 1 plus h. And then I have minus f of minus 1 divided by h. H goes to 0. So this is the first step. I write the formula for the given a. There are two things that I have to take care of. One is f of minus 1, which is very simple. So I told you that this is always good to have this diagram in your head. The function is a black box, is doing something. You send x in. Every function has its own functionality. Yes, in this case, what I send in x, the function will take that x from me, which I call the input, and then raise it to power 3, multiplies that by 2, and then subtracts 2 from it and gives it back to me. So this is the way that you need to think about the functionality of this function. So of course you don't need to write it down, but this is the way that you have to imagine it. Okay, so in this case, what is f of minus 1? F of minus 1 means that I am sending my minus 1 in, but the function will always do the same thing. It takes my input, which is minus 1, raises it to power 3, multiplies it by 2, and subtracts 2 from it. That's the functionality. Yeah, so what's the answer? It's minus 2, minus 1, minus 2 is minus 4. Yes? And then when I do the same thing here, f of minus 1 plus h, what is the meaning of this? Again, the function will do the same thing. It will take my input, which is this one this time, and raises it to power 3, multiplies that by 2, subtracts 2 from it. Yes? So that is what I have. So I can plug them here into the formula. So f prime. So this is usually a common mistake. I don't know why the students sometimes make that mistake. So is that understandable what I'm doing? Okay. So here, I continue. So this becomes the limit. The first one here is this. So it is 2 times minus 1 plus h to the third power minus 2. And then I have a minus sign in the formula. And then I have f of minus 1 is also negative 4. So please make sure that you are not messing the minus signs. And then divided by h. H goes to 0. And then you have to calculate this limit. Calculating this limit is just a simple practice and simplification. H doesn't need any simplification ever because the denominator is always h. So what you have to be careful about is the numerator. Okay, in the numerator you have to expand, simplify, and factorize if necessary. So that is the idea. So expand, simplify, and factorize. But for expansion, this is not a formula that you already used to. So this is a squaring rule we know. But the third power is also in the formula sheet always. So make sure that you see it. It's on the first page of the formula sheet. And the formula is this. If I have a plus b to the third power, The formula is a little bit more complicated than the second power. It becomes the first one cubed plus 3 times the first one squared multiplied by the second one plus the 3 times of the first one multiplied by the second one squared, and finally plus the second one cubed. So that formula is on the first page of the formula sheet. So if you don't remember it, you can just use that to do this. So here minus 1 is playing the role of this A, and H is playing the role of this B. So I will use this formula, but in my head I replace minus 1 for A and H for B. Okay? So let us continue here. So this becomes the limit. So be careful. I have also seen some students multiply 2 in first. That's not possible because the power has the priority. The power has the priority. Okay? So this becomes 2. This becomes the first one cubed. So let me be patient and write it down once. So, and then I will have 3, the first one squared, multiplied by the second one, plus 3 times the first one multiplied by the second one squared, and then finally plus the second one cubed. And then I have minus 2 here, minus 4 here, so it becomes positive 2. Yes? And then I divide everything by h, and h goes to 0. Okay, as I told you that you have to be patient and simplify. So this becomes the limit. So this is minus 1 to power 3, which is minus 1, and I multiply it by 2, it becomes minus 2. So this is 1, 3h, and multiplied by 2, so it becomes 6h. This is minus 3h squared, multiplied by 2, it becomes minus 6h squared. And this is h cubed multiplied by 2, so it becomes 2h cubed. And then finally at the end I have positive 2, and then divided by h. H goes to 0. Okay? And then, so if you don't mind, let me continue here. So what happens? This 2 and this 2 are gone. And then between this and that, I can factor a 2h out. Yes? So this becomes the limit of 2h. And then from here, 3 is left. From here, minus 3h is left. And from here, h squared is left. Yes, is that right? Always it doesn't hurt if you test it. So if you multiply this back, it becomes 6h, that's correct. If I multiply this back, it becomes that one, and that's also correct. And then divided by h goes to 0. So then what happens? This h now can be simplified. So be careful, h cannot be simplified in this form. You can only simplify common factors, not summands. Okay, so I simplify them. So what is left for me is the limit of 2, 3 minus 3h plus h squared, and h goes to 0, yes? Okay, so now that I do not have any denominators making problem for me, I can simply replace h with 0. So this is gone, this is gone, 3 is left, and a 2 here. So if you multiply them, it becomes 6. Yes? So that's the answer. So the answer to this problem, this is not the first example when I am teaching Ma3c to give you, but because now you are in Math 4, I hope that you can follow, okay? So f prime of minus 1 has a number 6. And if someone asks you, okay, this is abstract calculation, I'm just following a set of rules and I got a number. But what is the geometrical interpretation of this number? It means that if someone draws the graph of this function and finds a point on the graph whose x-coordinate is minus 1 and draw a tangent line at that point, the slope of that tangent line is 6. So this is also important to understand what is the meaning. We can say that, for example, if I ask you, is this f differentiable at minus 1? What do you say?
Yes.
Yes, because differentiability means the derivative exists, and derivative exists and it is equal to 6, so we can say that the function is differentiable. Yes.
What doesn't the derivative exist?
This is not part of a high school lesson. Sometimes we have a sharp point. I will talk a little bit about them from graphical points of view, not from analytic points of view. But for example, if I have a sharp point, we will discuss about this. The function is not differentiable at sharp points. So that's a good indication. If something happens for the derivative that doesn't exist, so it means that there is some sharp point going on, or discontinuity, or vertical. So you might also have a vertical tangent line. If you have a vertical tangent line, the slope of vertical lines, they don't exist. So in those cases, 3 cases, sharp points, vertical tangent lines, and discontinuity. For example, if a function has a break at some point, the function is not differentiable there. I will talk about them. I want you to know them because that's important, but only from graphical points of view. So by looking at the graph, you can understand where the function is not differentiable. But to understand why, for these cases, the limit does not exist is beyond the high school level. Of course, you will study them immediately in the first year of university. It's not a very big deal, but for some reason it is not part of your course. Anyway, so is that clear? Okay. But as you see, do you agree with me that this is boring? Okay, so what we had, Leibniz was going to solve the problem. So first, this is the human nature. When you solve the problem, you become excited, and then little by little, oh, you get bored. So this is the human nature, and probably it's the motive of progressing, yes? Anyway, so he told himself, okay, I solved the problem. Theoretically, the problem is solved. So I was able to come up with a formula that gives me the slope of the tangent line. Using that, I was able to find an equation for the tangent line. For example, if I ask you to calculate the tangent line, so if I ask you to find an equation for the tangent line, this is not wanted here, but let us just go one step. If I ask you to find an equation for the tangent line, do you remember? How should we do that? There is a formula. It's a y. I hope that I talked about this, yes. Y minus y node is equal to k x minus x node. It is not wanted in this problem, but let us say that it wants to find an equation. So you are supposed to write a number for y0, x0, and k. K is the same number that you got here. So what is x0 here? x0 and y0 is 1 point on the tangent line. Of course, from the tangent line, you don't have access to other points. You don't know anything about the other points. If you knew, of course, you could use them. But now you have only access to the point of tangency. Yes? So the point of tangency, x coordinate is -1. What is the y coordinate? We already calculated the y coordinate is -4. Yes? So it means that if you insist to write an equation for the tangent line, you can replace y0 with -4, and then replace this with number 6, and then x minus -1, and simplify this a little bit. So that's an equation for the tangent. Okay, so theoretically, we were able to solve our problem. At least I was able to solve it for this simple function. But you see that what is happening. First of all, even if I can solve the problem in this way, it is boring. So you see the calculation is rather lengthy, even for the very simple function. This is not a complicated function at all, yes? It's a very simple polynomial function, but it was quite lengthy to be able to answer that. So theoretically, the problem is solved, but technically, there are some problems left. First of all, this is boring calculation over and over again. The second one is that sometimes it is impossible. Let us say that you insist you want to do the boring job. But if I change this function to a complicated function, then you completely get stuck if you want to calculate the limits. Calculating limits in general is not an easy task. So if I make the function complicated, this is not just that, okay, I will sit down and then do it. Yeah, sometimes it is impossible. So even though theoretically the problem is solved, but technically the problem is not solved yet, because I want to be able to extend the same idea to as many functions as possible. Okay, now I am asking you, and this is, by the way, is a very sensitive calculation. For example, let us assume that I sometimes say that, okay, sorry for this, I made a mistake, you are supposed to calculate f prime of 0. So what you have to do? I said that, okay, sorry, I didn't mean to calculate f prime of -1. I actually wanted to say calculate f prime of 0. So what you're supposed to do, yes?
Do it all over again.
All over again. So don't think that you can just refine it a little bit. Because if I change -1 to 0, all of these numbers and every details will change. So you have to redo it again. Okay? And then after that, you do it. I said, sorry, I really don't know what to say, but I meant f prime of 1. Then what you do?
All over again.
All over again. And then if I say sorry, then probably you will actually start doubting about my mental health. And then you will say that, okay, but let us say that you have a mentally sick teacher, okay? But how can you deal with a mentally sick teacher if he insisted to change the number and gives back to you? This mentally sick teacher is the mentality of mathematicians. They are both the students and mentally sick teacher in one body. Okay, so they actually poke themselves, yes? So they're sitting still so they cannot sleep, let us do this. Okay, so this is the character that mathematicians, they pose the questions to themselves and then try to solve them. Okay, so if you want to get rid of that crazy teacher, so what do? Yes? Yes. So what do? He said that, okay, this teacher is not reliable. So instead of calculating it for f prime of -1, let me calculate f prime of a for any a. Of course, the calculation becomes slightly harder because instead of working with a number, you are still working with the letter a, and algebra is a little bit harder than arithmetic. But the price that you get, your reward that you get back is that, okay, you do it once, and if the teacher changes the idea from -1 to 0, you just change a to 0 in your final formula. Okay, so that was the mentality of mathematicians as well. Okay, so they wanted to find a formula that works for them to calculate this derivative. So they want to forego about these wrong calculations. But there is another obstacle here. So what is that? So we came to this point that we want to invent formulas or formula, because I hope that you agree there is not one formula. How many functions are out there? Infinitely many. Okay? You can find a formula for each single function, but it is practically impossible. Okay, so now you are a mathematician, so you are facing this problem. How do you solve it? Yes?
You make one formula for each shape of the graph. It's second degree function or a linear function.
Okay, so what the gist of your saying is we categorize the functions. Yes? Because that's the only thing. I just want you to feel you will do the same thing if you were a mathematician yourself. So it is completely natural, okay? So first thing, we solved our problem, so we were motivated by that question. We came so far. And then we realized that, okay, when excitement is settled down, we see that this becomes boring, and sometimes formidable task, we cannot do it. So then we start thinking again, what can I do to make it more efficient? So that's also extremely important, to make the calculation efficient. Okay, then you say that, okay, if I want to make it efficient, so let me develop some formulas. But then the problem is that there are infinitely many functions out there to develop formula for which one. And then the first thing comes to mind is that, okay, even though I have infinitely many functions out there, but if I look closely, they can be categorized in different categories. And if I can find a formula for each category, then it is better than nothing. Yes? So this is the way that we want to do it. We exactly want to do it. That is the philosophy behind formula sheet. The philosophy of the formula sheet or the handbook of mathematics is not to underestimate the role of memory in learning as you do. It means that was the reason that people do it. Yes? Okay, now I'm asking you, so how do you categorize your functions? Is the logic clear what we are going to do? So we want to categorize our functions. And then because we are human beings, we don't start with the hardest even possible problem. We start with the easiest one, and that is good. Yes? So then it means that what do you ask yourself? You ask yourself, what is the easiest function that I can face? Yes? So let me find a formula for the easiest possible functions. That is one category. And then I increase the level of difficulty of my category a little bit and find another formula and something like that. Okay? Okay, what is the easiest function that you can imagine? You said linear. So can you give me an example of a linear function? The simplest linear function.
Y is x.
Y is x. Yes, is the simplest linear function. But we have a little bit simpler functions than that before linear. Yes? A constant function. Okay? A constant function is a function like this. F of x. So f of x is, for example, 5. That's a constant function. So if you want to visualize it, f is a machine. Yes? You send x in. It doesn't care what you send in. The answer is 5. Yes? So these constant functions are dictators. So they don't care what you say. They follow their own rules. Yes, the answer is 5, whatever you say. And we have different dictators around the world probably. So the name of those functions are different. Okay, so that is the simplest possible function. But if I want to categorize all constant functions, instead of writing f of x 5, instead of writing f of x equal to square root of 2, I just simply write f of x equals to what? A constant number c. Okay, so let me just draw this table here for you. So now that you realize what we are supposed to do, we want to categorize our functions and calculate the derivatives once for all. Okay, so f and then f prime. You have this table in the formula sheet. In Ma3c, you had some lines of it, but in Ma4, we will increase these lines a little bit more. Okay, so the first function that you have here, so if you have a constant function. So what is the derivative of a constant function? 0. Why is that? So here, so let me write the formula here. Instead of saying f prime of a, so if you don't mind, let me write f prime of x. F prime of x is the same as f prime of a. The only change is that I have made a to x. So it becomes f of x plus h minus f of x, and then divided by h goes to 0. Okay, let me ask you this question. I want you to answer this one. Of course, I don't have time to go through all the proofs that we want to, but some of them are easy. I want to see that everything is coming from this formula. Okay, so can you tell me what is f of h is always h goes to 0 as always. This minus sign is always there. So what can I write for f of x for this function? C. So what can I write for f of x plus h? C again, because it doesn't care what you send in, the answer is always C. When you send x in, the answer is C. Now you change your input and you send x plus h in, the answer is still C. So it becomes C minus C. And then C minus C is 0, 0 over h is 0, and the limit of 0 is 0. So that's the proof. Okay? So it means that everything, by the way, everything on that table is somehow coming from this formula. Okay? So the derivative of constant functions is 0. Yes? It doesn't matter. I have seen a lot of these kinds of mistakes. So if I give you this function, f of x is equal to square root of 2. What is the, let me write this example. I don't know, even though every time I emphasize this, but still I see some students make mistakes. So let me write some examples. F of x is equal to a square root of 2. What is the derivative? What is the derivative? 0. So f of x is the famous pi number. What is the derivative? 0. So I just want you to understand, it doesn't matter if it is a letter or whatever. If it is a constant, the derivative is 0. For example, f of x equals to tangent of 45 degrees. Well, let me make it even harder. So tangent of 22,5 degrees, I don't know, plus ln of, you haven't studied ln, you have studied ln or not? Yes, ln of 5. So what's the derivative?
0.
So, okay, so that is important. It doesn't matter what constant is. If the function is a constant, it doesn't matter how complicated the constant is, the derivative is 0. Okay, and now we go to the next level. So then, as you said, that's a linear function. Okay, but a linear function is of a function of this type. So a function of this type f of x is equal to kx plus n. That's a linear function. Okay. But before going that, let us consider the simplest possible scenario. Okay, the simplest possible scenario is f of x is equal to x. So what is the derivative of f of x equals to x? Do you remember it from your previous studies? It is 1. Why is that, by the way? So let us immediately understand it from this formula point of view. So let us say that f of x is equal to x, and I am supposed to calculate f prime of x. So it becomes the limit, the denominator is h goes to 0, and then the minus sign is there. So f of x in this case is what? X. And then f of x plus h is x plus h. Because, by the way, this is a dictator, but this is probably a liberal, yes? Because whatever you say, it says okay. When you send x in, it gives you x back. Okay? So it means that when I send x plus h to this machine, what do I get as an output? X plus h. And then what you see, x and x are gone, and h over h is 1. The limit of 1 is also 1. So that's the reason. So the derivative of x is 1, but you have to memorize it. I really wanted to memorize some of these simple ones. Okay, but the problem is that, let us say this function to you, x plus 2. So what is the derivative of x plus 2? Of course, you know it from your previous studies, but I hope that you understand that because the derivative of x is 1, it is not automatically guaranteed that the derivative of x plus 2 is also 1. So I need another set of rules. I need another rule that tells me if I know that, so do I know the derivative of x individually? Yes. Do I know the derivative of 2 individually?
Yes.
Yes, but there is no guarantee yet that what is the derivative of some of two functions that I know their derivatives. And there is another rule, so that I will write them as a separate rules. These are rules for particular functions, but we have some generic rules. Okay, so I want to add them on that table. So let me add them exactly here. So one rule is this. So the general rules, yes? The first rule is that if you have two functions, I know the derivative of f alone, I know g, the derivative of g alone. My question is that, do I know the derivative of the sum? The answer is yes, but it needs proof, okay? So it becomes the derivative of the first one plus the derivative of the second one. So that is a rule independent of what f and g are. We don't care, okay? Whatever f and g are, this is a generic rule. Okay, so the second thing is that what happens if I know the derivatives of f and g, I will subtract them, then I want to take the derivative of the combination. The rule is still the same, so with f prime minus g prime, so you can individually differentiate and subtract them. Yes? And then don't push this analogy further. This is the lesson that we will learn. So don't think that if I multiply two functions and I want to take the derivative, it becomes f prime dot g prime. So please write it down and cross it over. This will be one important lesson in this chapter. So what will be the derivative of the product? Okay, and the same story for this one. Don't think that f divided by g prime is equal to f prime over g prime. So the formula for the derivative of the sum and the derivative of the difference was natural, I would say. But if you want to push this analogy further for the multiplication and division, you will get wrong for this. Okay, so don't push this analogy further. But for this case, For this case, I have an exception that you learned in Ma3c. If the product is not the product of two functions, is a product of a number, constant number by a function. So let us say that I have a constant number multiplied by a function, and then I want to find the derivative. In that case, you don't even bother about c at all. So you just put c there, and then you differentiate only your function. Okay, so this is correct. So these three formulas we need. Okay, I don't have time to go through proof of them. If I can't find the time, I will show you why these are true. Okay, so now can I make sure that I know the derivative of this one? In principle, if you want to calculate the derivative of this, in Ma3c, you just gave me the answer 1. Still, I want you to do the same thing, but I want you to have a little bit deeper understanding. If someone asks you why the derivative of x plus 2 is 1, okay, the reason that the derivative of this is again 1 is not only the formula for x. It is the formula for x, the formula for the constant, and these together. So you have to use 3 of them to be able to write that this is 1. Why? Because you say that this is a sum. The derivative of the sum, I use this rule first. It becomes the derivative of x plus the derivative of 2. It is extremely important in math for derivative, you think in that way. I'm not insisting to write so many things, but you need to think in that way, okay? And then you ask yourself, do I know the derivative of x? The answer is 1 plus. Do I know the derivative of 2? The answer is 0. So the answer to this is again 1. But you be careful. The derivative of x equals to 1 only needs the formula for derivative of x. But the derivative of x plus 2 is equal to 1 needs 3 formulas. Yes? 1 addition formula, 1 the formula for the derivative of x, 1 the formula for the derivative of a constant. Okay? So this is important to think in that. Any questions so far? Okay, so let me give this. This is called, I don't know, the sum rule, the addition rule, the subtraction rule. Okay, so these things I will actually refer them to this. Okay, but of course, then you want to increase the level of difficulty. So what should I do? The second order, what is the derivative of x squared? What is the derivative of x cubed? And so forth. Okay. But there is no time for going through the proof of them. It turns out that the derivative of all these type of functions, x to power a, no matter what a goes down, and then you write x, you subtract 1 unit from the exponent. Okay, so this is very important formula. Okay. But by the way, to understand this formula in its complete form, you have to wait for the university, even though this function is extremely simple function, but proving it in general is not that easy at all. So you have to know a lot of things, okay? So here I just emphasize that a is any real number. Of course, except 0, because x to power 0 is just 1, and the derivative of that one is what? 0. Okay, so this is what you see in the formula sheet. So you do not see the formula for the derivative of x in the formula sheet. Okay, they expect you to use this formula over and over again. But I will write some special versions of this formula. I really recommend you to memorize them. Otherwise, you will be bogged down in very messy calculations for no reason. Okay, so for example, if I give you this function, let me give you an example that uses this formula extensively. Okay, so example. So this is a very important example, okay? Very simple, but very important. I'm just giving you a lot of different functions that only uses that single formula, okay? And of course, sometimes these generic formulas. So determine, so in each case, determine f prime of x. Okay, so number one, I would say, for example, f of x is equal to 2x cubed minus 5x squared plus square root of 2. Okay, I want to find the derivative of this function. I write everything in detail, but I don't want you to write so many things. If I give this in the exam, I usually want you to write immediately the final answer. But I intentionally go through all the details that is needed, because this way of thinking is needed for Math 4. So if I want to calculate the derivative of this function, what do I do in principle? I have to take the derivative of the whole combination you see. Okay? So how you think about the problem first? So you see I have subtraction of two functions, addition of another function. So I need two rules first. The generic rule here for addition and the generic rule for subtraction. So it allows me to write 2x cubed prime minus 5x squared prime plus the square root of 2 prime. So which rules I used? For this one, I used this second rule. Yes. For the addition ones, I use the first one. Okay, but which rule I will use now, do you think? Yes?
The third one.
The third one, CF, yes? So this is a constant multiplied by my function. So I don't even bother to think about the constant. I concentrate on the differentiating this function. Yes? And then the same story here. I have my minus sign. 5 is multiplied by x squared. So I don't bother about my multiplicative constant, and I differentiate this. And of course, the derivative of square root of 2 is 0, because square root of 2 is constant. So this is the first time I use one formula from this table. Okay? But now I use formulas, the second row of that table for this one and for that one. So what happens? 2 I copy and paste. But what is the derivative of 3x squared? Sorry, x cubed. 3x goes down and it becomes x squared. And then minus 5, 2 goes down, x becomes to power 1, which I don't need to write. Yes? And then finally, what will be the answer? It becomes 6x squared minus 10x. Okay? I don't want you to write so many things. I expect you, when I give you this, you can immediately, in a matter of seconds, write this one. But I want you to understand that so this rule was used, this rule was used, this rule was used, this rule was used, this rule was used. So I want you to understand which rules are we using to come up with that answer. Is that clear? Okay. So number 2. So let me give you another function. F of x is equal to 2x squared times x minus 1 to the power of 2. So let me make it 5. Okay, what should I do here? So how can I calculate the derivative? This is important to understand. First of all, what is this? What is the operation here? The operation between this one and that one is multiplication. So the rule for multiplication haven't been studied yet, and it is not this simple version. So you cannot use that right away. Okay, so what should I do then? Yes? Expand and multiply, yes? So what happens, it becomes 2x5, and then, so this is, you see, the differentiation process here started immediately. Differentiation is going from the function to its derivative. This process is called differentiation. So here I was able to start differentiation immediately, But here I cannot start differentiation immediately because I do not have the formula like this in my table. So I have to adjust the form in a way that I can use the information that I have in the table. So this motivates you to expand that 2x and plus 1. Yes? And then you multiply this in, so it becomes 2x7 minus 4 x to the power of 6, and then plus 2x to the power of 5. So instead of concentrating on this function, you simplify it first. It is inevitable because I do not have any formula in my table that tells me how to do it with this function. So I have to decompose it in a way that I can use that information on the table. So what should I write now? So now do this one in your head. What's the answer? Is it everything is now clear? So what can I do? Just do it in your head. What's the answer?
14x.
14x to the power of 6, and then minus 24x to the power of 5 plus 10x to the power of 4, and that's your answer. Okay? But immediately, if you have a curious mathematical mind, there is one question that you might ask. What that question is? Yes?
The second derivative.
No, the second derivative is coming later, okay? Now, the question about this problem is that what happens if instead of 2 I have 20? Okay, so that's a very simple question. These are theoretically not important questions. These are practically important questions, yes? So I was able to do it for this, but if I raise it to power 20, okay, the question is that, okay, even though I can sit down and multiply x minus 1 by itself 20 times, but practically it is hard. So have this question in the back of your head. So this we really need. If I can find the formula for the derivative of the product, it is a good progress because I will be able to solve this not using expansion, but using the product rule. Okay? So anyway, so we go to another question. Number 3. So let us write this one. F of x equals to the square root of x. This I emphasize to memorize it, please. This formula is not in the formula sheet. They expect you to do it all the time like this to find it. But this becomes really hand tying, you know. It's better to know the formula. So I will write it with a different color here at the end. So if I ask you to find the derivative of this one, so what can I do? The only information that I have is my table and these generic formulas. So I have to change the form of this function in a way that is similar to one of these. So yes?
Write it as an exponent.
As an exponent. If you have forgotten, these are also in the formula sheets, but let me write them here for you. So if you have this a here is a to the power of 1/2, and if you have the nth root of a, it is a to the power of 1 over n. Of course, you know that when you don't write any number here, it means it is 2. And then we can also write something more. If I have n here and I have m here, then you can write a to the power of m over n. I don't remember if it is in the formula sheet or not, but all of them are needed here. Oh. Okay, so now the first thing you do, you cannot start differentiation process right away because the function given to you doesn't look like these functions yet. So what I do, the first thing I do, I will write it in the form of x to the power of 1, and then I start calculating the derivative. So what is the derivative? X to a. Now compare this one with the second line. A is 1/2 here, so a goes down, and then x to the power of what a is minus 1. Understandable? But 1 over 2 minus 1, I can write it as this. Yes? So that's the end of the story, but I don't want you to stop there because you also need to know how to simplify things sometimes. So what I do, I will continue, even though technically the problem is finished here, okay? But let me continue. Continue, I write 1 over 2 here. I have a negative power. First, I want to get rid of negative powers, so I bring it down in the denominator, make it 1 over 2. So which formula I'm using? I'm using this formula. Yes? Okay, but now there is a better name for this one. What is that? Square root of x. So it becomes 1 over 2, 1 over square root of x. And then I have to multiply it, because that's multiplication. And 1 times 1 is 1, 2 times is 2 square root of x. I really urge you to remember this. So this is a consequence of this formula. So a square root of x derivative is 1 over 2 square root of x. If you don't memorize this formula, which is not in your formula sheet, okay, then you have to do all the calculations every time you want to calculate the derivative of square root of x. Is that right? Okay, so let me go to the next question. So number 4. So let me write f of x to be x to the power of 2x to the power of 3 multiplied by the third root of x to the power of 2. So I want to differentiate this function. So what should I do now? We don't need this anymore, so let me clean that. So is the reading clear? So 2 times x cubed times the third root of x squared. So we want to find the derivative of this function. So what should I do? Your strategy, your goal is to rewrite, because you see that this function is not in my table. So this is the only skill that you need to learn, to change, to transform it in a way that you can use the information in your table. So what should I do? Yes?
2x cubed times x to the power of 2 over 3.
2 over 3, okay. So this is also a common mistake. This is correct. This is not a common mistake. That was correct. But let us see how you proceed. That is important. So f of x is 2x cubed times x to the power of 2/3. Is that understandable for everyone? Yes, I just copied and pasted the first part. Yes, and for this one, I use that formula. Okay, a is x, m is 2, and n is 3, and I use that. So that. Okay. The common mistake is that students write this, but they start differentiating right away. They use this formula for this one, and they answer 6x squared. They also use the same formula for this one. They bring 2/3 down and subtract 1 from it. Is it true or false? Yes? Why? Multiplied. And I insisted that for multiplication, you are not allowed to do them one by one. Okay? So have this in mind. If you have multiplication, even if you know how to do this and how to do this, which in this case we know, but it doesn't mean that I am allowed to take this derivative of this one and that one individually. Okay, so what should I do?
Maybe you add exponents.
Exponents. So there is a rule that if I want to multiply two powers with the same bases, what I can do, I can write the same base and add the exponents. And of course I have a 2 here. You have to do this one first. Okay, can you do it in your head? 3 plus 2/3, what is that? Yes, 11 over 3. So the first thing that you are supposed to do is to transform your function in a doable way so that I can use the information there. So what should I do then? Now I start differentiating process. So f prime of x becomes what? 2 is a multiplicative constant. Multiplicative constant is always okay, yes? Multiplicative constant follows this rule. So I just copy and paste 2. And for that one, what I'm supposed to do, 11 over 3 plays the role of a in the second row of my column, the formulas. So 1 over 3 goes down, x to the power of 1 over 3, 1 unit less. Yes, is that understandable? And then what happens? 2 multiplied by that, it becomes what? It becomes 22 over 3. Yes, and this one becomes x to the power of 8 over 3. So that is your final answer. If you prefer, of course, you can write it with simplifications. This is not needed, but let me just do it for your understanding. So if you insist to continue, you can write it in the using of the third sign. So you write it, you put a radical sign here, you put x below it. This number in the denominator goes here. This number in the numerator goes here. Yes? And then, of course, you can even simplify it more if you want to. Okay, how? Because this, you can write it as x to power 2 to power 3 times x to power 2, yes? Because x to the power of 2 to the power of 3 is x to the power 6 times x to the power 2 is x to the power 8. But then because this number and that number are the same, x to the power 2 can go outside of the third sign. So this becomes 22, 3, x to the power 2. But this power is 2. It cannot go out. It remains there. Usually in math books, they prefer to write it in that way. Okay? But for this case, if you stop here, that's acceptable. Yes? Is that clear? Any questions? Okay, so let me give you another example. Let us see how we do that. So what number was this? This was number 4. So number 5. Number 5. So f of x equals to what? Say square root of x multiplied by x plus 1 to power 2 minus 3x plus pi to the power of 3. So how can I take the derivative here? So I want to wait for you. Yeah, please do it. Okay, could you do that? Yes. So what I'm supposed to do? So you see again, let me review everything. So I have a function. I have only these rules at my disposal. The generic rules, 3 of them, and 2 rows here. So then it means that my function is not exactly like any one of those ones. So I have to decompose it in a way that I can use those information there. So what should I do first? Yes?
Use the second rule.
Yes?
To separate the
Yes.
square root of x.
So yeah, in principle we can do that, but those rules you know about them, but you don't need to write them down. Okay? So yes, the first thing I will do is to expand. Yes. Yeah, but what you telling is completely true. So what I do, I will first write this square root of x is to the power of 2. The first one is square 2 times the first one times the second one plus the second one minus 3x plus pi to the power of 3. And then you know I have to multiply this in, so it becomes x squared square root of x, then 2x square root of x, then plus square root of x. Then I have minus 3x plus pi cubed. Okay, now you have experience from the previous exercise. What I'm supposed to do here, do I know the derivative of x squared? The answer is yes, it is 2x. Do I know the derivative of a square root of x? Yes, the answer is on the board. But can I use the derivative of this one and this one individually? Yes or no? No, because that's a product. If it's a product, it is not true that I can do them separately. Okay, so I have to combine them for the time being. But we will learn about the product rule later. Okay, so here, this is the only option you have. So you write x squared, and then you know what the name is. is x to the power of 1/2 plus 2x and times x to the power of 1/2. I prefer not to change this, okay, because I have this formula in my memory. If you don't have that formula in your memory, because it is not in the formula sheet, you also have to change the form of that one. But I prefer not to do it because I have it in my memory. Here is on the board. This is the reason I do that for these two, but not for that one. And then minus 3x plus pi cubed, yes? And then, as you learned before, I combined them. So here, if you can do some calculations in your head, just do that. So I write x and I add the exponent. What is the exponents? What's the answer? 2.5, or let me write it as 5/2 to be consistent with fractions. So then 2, I add the exponents. Exponent here is 1, and that one, it becomes 3/2. I don't touch this because I want to use the formula on the board, and then pi cubed. Okay, now f prime of x becomes clear. So this goes down, what happens? 5/2 x to the power of, can you do it in your head? 5/2 minus 1 unit. 5/2 minus 1, 1 means 2/2, so it becomes 3/2. So try to do these calculations in your head. Okay? So then the next one, 3/2 goes down. You have a 2 there. 3/2 goes down. These 2 and that 2 are cancelled, so you are left with 3. And then x to the power of 1 unit less. So what is that in your head? 3/2 minus 1. 1/2. For this one, if you have it in your memory, I can just use it. It's 1/2 square root of x. And what is the answer for minus 3x? Is minus 3. And that one is also very simple, 3 pi squared, yes? Yes. So I just wanted to see how many of you wrote this? None of you. Okay, that's good. So 3 pi squared is wrong, yes? But the answer is 0, yes? Because pi/3 is what? Pi/3 is a constant. So no matter how we write the constant, so it is 0. And that's your answer. Okay? Yes.
Because it's wrong to write the exponents as real numbers instead of fractions.
If they are exact numbers, no. But if your fraction is x to the power of 1/3 and then you write x to the power of 0, something like that, that is wrong. Yes, because that's an approximation. I want exact values. Yes? Yeah, that's not wrong. Okay, but there are something more we can do with this single formula. So I'm just giving you the diversity of all type of functions that you can still use the same formula. Okay, another formula is that what happens if I have a denominator in my function. So let us go to number 6. Let me start with a very simple one first. F of x is equal to, where is my pen? F of x is equal to 1/x. I want to differentiate this function. So how should I differentiate this function? What? Yes?
Could you rewrite 1/x as x to the power
Minus 1. That is the only way, okay? So what we do, we write f of x equals to x to the power of minus 1. And then let me write it down. So f prime of x, this minus 1 goes down, multiplied by x to whatever you have on top, 1 unit less. So that's the way that we do it. So, but this becomes minus 1, which I don't need to write minus 1, I just write minus, x to the power of minus 2. It is good to stop there, it's not wrong, but I prefer to continue because I didn't start with negative powers. I don't want to end up with negative powers. That is subjective thing. So you put minus sign here, and then you bring it back to the denominator. So the derivative of 1/x is simply minus 1/x squared. Okay? So what about this one? Number 7, f of x is equal to, let me write 1/3 x to the power of 5. So what should I do here? Anyone else? Yes?
Write as 3x to the power -1.
No, that is you know that I have a lot of experience of I know what makes the students to think wrongly. So what did you say exactly?
3x powered -1.
Something like this?
Yeah.
No. And that was my intention of writing this. Yes?
1/3 times x.
1/3. Because if you want to bring 3 up as well, so you have to write 3 to the power of -1. Okay? But I don't need to do that because 3 is a constant. So the way that you have to think about this problem, this is the way I think, but doesn't mean that I write so many things. But I think in that way. This, I write it as 1/3 in my head times that. Okay? And this becomes a multiplicative constant, so I don't need to touch it at all because multiplicative constant doesn't pose any problem for me. And then this one, I bring it up. Yes? You don't need to write so many things. You can just directly write that, okay? But then I have differentiated. So what is the derivative? 1/3 is a multiplicative constant, so I just put it there. And then I know that -5 goes down. X to the power of -5 minus 1. Yes? You don't need to write so many things. You can just do this in your head. -5 times a third becomes -5/3. And this becomes x to the power of -6. Differentiation process is finished here. But sometimes if you want to simplify things, I hope that you immediately understand that this can be written in this form. But the last line is not necessary. You can stop here as well. So there is a minus sign, yes? Any questions? Okay, so let me give you another type of examples. This is also very important. So you see, this is not a conceptual lesson anymore. It's just a technical lesson. So this is something that needs improving your skills. It doesn't depend on your understanding of the concept. The concept was we talked about. So 8, what happens do you think if I have this scenario? So f of x, let me give a simple example first. X squared plus 1 over x. I want to differentiate this function. So, do you know the derivative of the numerator?
Yes.
Yes, which is 2x. Do you know the derivative of the denominator? Which is 1. But can I take the derivative of the numerator and denominator separately? That's exactly this warning. You're not allowed to do that. So, what do you say?
You can write x squared plus 1 times x to power -1.
And then? Yes?
Maybe you can write them separately. X squared divided by x plus 1.
I prefer this one, but what you said is also correct. Okay, so that is not wrong. I will tell. Let me follow this, because you know that if I give you a over b plus c over d, c over b, and I ask you to combine them, what do you do?
A plus c divided by
Yes, because it becomes a plus c over b. But because this is equality, it doesn't mean that if I can go from here to here, I can also go back from here to here. Yes? So if I have the sum or difference of, so I can write it somewhere for you. So if I have a plus or minus b plus or minus c plus or minus etc. divided by d, if you want, you can write a over d separately plus or minus b over d separately plus or minus c over d separately plus or minus. That's important. Okay? So here I will follow the same rule. So I have the sum of 2 divided by one single thing. So what can I do? This becomes x squared over x plus 1 over x. Okay? So then I simplify x squared, because when I am dealing with this one, I can ignore this. X squared over x is what? It's simply x. But then I learned what to do with this one. I bring it up. Yes? And then I start differentiation. So f prime of x is equal to the derivative of x is 1. Minus 1 goes down, x to the power of minus 2. So the answer would be 1 minus 1 over x squared. So the derivative of that function is this function. Yes? Let me give you one more example, which is a little bit more. I want to wait for you. So, by the way, if I change it the other way around, we cannot do it right now. So if I give you, I will not give you for the time being this function. Okay, let me give it g of x. If I give you x over x squared plus 1, I want you to understand that we cannot do this trick. Yes? Because this trick needs you have more than one expressions in the numerator and only one single expression in the denominator. But here, I need really a rule for which I have division. And for this one, I really need this rule. Okay? So these divisions so far is only the cases that you can separate them. But here I cannot separate them. Do you have any doubt about it? You cannot write x over x squared plus x over 1. Okay? That is wrong. This separation happens if you have more than one thing in the numerator and one thing in the denominator, not the other way around. So I cannot solve this problem for you now unless we know this rule. Okay? Okay. It is important to know your limitations. Okay? And now let me give you one example so that you can do it yourself. It is lengthy, but I want you to actually do it yourself. So what we do here, so let me write number 9. F of x is equal to, let me write square root of x. So let me not make it so complicated. Okay, so let me, in the denominator, I give you 2/3 root of x. And in the numerator, I give you x times x plus 1. I want to wait for you, okay? You know that this chapter is only about these rules, okay? So you have to learn how to differentiate properly. Extremely important. Okay, here I hope that you could solve it. The details are not that important. I want you to feel that you are on track, yes? And by the way, I wanted to give you a very diversity of problems. You might even didn't imagine that this simple formula only combined with this can help you to solve the derivative of so diversity of functions. Okay? So this was a good way that we started because we wanted to categorize the functions. And just only this single formula enables us to solve a very different functions of different flavors, you know, including the square root signs, divisions, multiplications, and things like that. Okay, so what we do, so everyone agrees that I have to multiply that, yes? Could you feel that yourself? Okay, so, and then what I do, I multiply this in, so it becomes x squared plus x. And what is your feeling about this one, by the experience you got so far? Yeah, so 2 I cannot do anything with that, so I can write 2 to the power of 1 over 3. So then what do you see? You see of these type of questions, yes? But a little bit more involved. So what I can do, I can write it as, this 2, I don't know how you write it, you can write it as x squared over 2x to the power of 1/3 plus x over 2x to the power of 1/3, yes? But when you divide, you are supposed to what to do with exponents? So do you know the formula is a to the power of m times a to power n is a to power m plus n. But if you have a to power m divided by a to power n, you write a m minus n. Yes? So what you do here, the exponent is 2, the exponent is 1/3, and then you know what to do with this 2 in the denominator. You just write it as 1 over 2, yes? Because 2 in the denominator is 1 over 2. And then this one and that one, I can write it as x to the power of 2 minus 1/3. Yes? Everyone happy with this? This can be written like this. Yes? And the next one, it becomes 1/2 again. X to the power of 1 minus 1/3. Yes? So now you do some simple calculations. 2 minus 1/3, what is that number? 5 over 3. And then plus 1 over 2. X to the power of 2 over 3. So what I have done so far, I haven't even started differentiation. I was busy to make it in a way that I can start differentiation. Now I start differentiation, so f prime of x, 1 over 2 is a multiplicative constant, so I don't touch it. But I know what to do with this part. 5 over 3 goes down, x to the power of 5 over 3, 1 unit, less. And then the same story here. So 1 over 2, 2 over 3 goes down, x to the power of 2 over 3 minus 1. And then the rest of it is again simplification. 5 times 1, 3 times 2, so it's 5 over 6. X to the power of, can you do this in your head? 5 over 3 minus 1. 1 means 3 over 3. So it is 2 over. And then 1 over 2 and these 2 are cancelled, so 1/3 is left. X to the power of 2/3 minus 1, which is minus 1/3, yes. And then simplification is not needed. So as far as you could get this answer right, you learned everything which was supposed to learn in this lesson. Yes.
I did a different way.
Yes.
I did the power of 2 to power minus 1 and
What?
I just reversed it.
This one?
Yeah.
No, you can reverse the whole thing.
No. Just I multiplied x squared plus x by 2 to power minus 1 times x to power minus 1/3.
And then you wrote it x squared plus x? No, that is a big mistake. Yes? Because you, in that case, whenever you give me a very complicated function, I start multiplying by some factors, make it simple, and take the answer at the end. What you can do like this. But you cannot get rid of it.
That was the thing. That was what I did.
Yeah, this is correct. And then you multiply this in. So that is exactly what you told here. I forgot to tell you. I told you that what you said is correct, but I prefer to do it in that way. Okay. What you are saying here, it means that you write this one, and then you write it as in this one and this one are the same. But then you can write this one as x to power minus 1, and then multiply it in. Yeah, that works always. My preference is to use this. But if you exactly know what you are doing, that's correct. But anyway, I hope that most of you could got this answer right. If you got it right, it means that you really learned what is needed to learn. So I will do this recap because there was one other famous formula in Ma3c that we didn't discuss here. Do you remember that one? Yes? E to some power. Yes? So I will discuss about those things. So these lessons are, even though I called them recap, but this is also a completion of what we had done before. Any questions?